talk about proving triangles similar. So we had 5 theorems that prove congruence last unit. Side, 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 angle, 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 side, angle, and hypotenuse leg. The good news, there's only 3 similarity theorems. So we've reduced your workload by 40%. Our first one is angle similarity. So if we remember back to yesterday when we were talking about our similar figures, in a similar figure, that was a good word, similar figure, all 3 corresponding angles were congruent. If we can prove we have 3 congruent angles, and we only really need to prove 2 because the triangle sum theorem tells us that if we have 2 that are the same, that third one has to be the same. If we can prove 2 congruent angles exist between 2 triangles, we can prove those are similar. So we look at number 1. Do we have any angles that jump out at us as congruent? Okay, so we got the vertical angles, right? So we've got these angles in here. So how would I name those angles? What? CED. We got to be specifical, man. Get specifical. And then GEF, right? Okay, we'll find out. We can find out. How did we know those were congruent? Because they're vertical. Do we have another congruent relationship? We've got parallel lines, which means we've probably got alternate interior or corresponding. What alphabet letter helps us prove alternate interior? Z. But this one's going to look a lot like an M, won't it? So if I go here, oh, Peter. Boom. What do I know is true about the corners of that Z or N? They are congruent. So I could say D is congruent to F. Yes, sir.
Does that mean that C is also congruent to D?
It does. But we can show that either with more alternate interior angles, or we could do it with the third angle theorem. Because if 2 angles of 2 different triangles are congruent, that third angle must also be congruent. Because there's only so much inside of a triangle it can be. It has to be congruent, because what will the inside of a triangle always add up to? 180. And if 2 angles are already taking up, say they took up 120 in each triangle, what is left for the third angle to be? 60. All day. So how do we know D was congruent to F? Alternate interior. So do we have 2 pairs of congruent angles? Yep. So if we've got 2 pairs, we can say our figures are similar. So we could say triangle, CDE is similar. See, I'm even in the habit of writing congruent over and over again.
Why did you write
To GFE. So we've got CDE is similar to GFE. What about number 3? What congruent angles do we have? So y is congruent to c, and because they're both right angles, and no matter what, right angles will always be congruent. And then each triangle is missing the third angle. So we need to either verify that S is 51 or that H is 39. Who do you want to look for? So measure of angle S plus 39. And I'm going to use the complementary theorem so we don't got to do math twice, equals 90. Why can I do the complement theorem there? Yep. So in a right triangle, the other two angles must be complementary because the right triangle's already taken up 90. So no matter what, the other two will only ever be 90. So we could, if we wanted, we could add the 90 in there and set it equal to 180. But this is just another way that we have an ability to go about our own path in math. Subtract 39 from both sides. Bum, 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 bum. Dun, 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 dun. As angle S measures out to be 51. 23. Oh, well, I mean, if you would have said 45 and 23 were the same, I could have given you a little credit. So we know the measure of S, so we know angle S is congruent to angle W, because both are 51. Now that we've got two congruent angles, what can we say about these triangles? Nope. They are similar. They are similar. So we'd say ESY ESY is similar to what? HWC. Number 5. Uh-oh. One of them rascally triangles and a triangle. Okay, so we've got a triangle within a triangle. Do we have any congruent relationships? What do we got? How do we know? So I like that you went there. Did they tell us they were parallel? No. So can we assume that they're parallel? Unfortunately not. Angle N is a shared angle. So it has to be congruent, but you cannot write in highlighter, dummy. So N is congruent to N. That is reflexive POC because they are shared angles. Guys, shared angles are going to pop up a lot in this unit. Not that we've got much more left in this unit. Because both of them should have angle N. How is it a shared angle? So when we look at the yellow triangle, what's the measure of angle N? We look at the green triangle, what's the measure of angle N? 67. So both triangles have angle N, so we can call them a shared angle, just like in the past we called them shared sides. All right, we need one more piece. Which one you want to find? You want to find that chunk right there of B? All right, let's find that one. So the measure of what do you want to call it? NBC? Plus 91 plus 67 equals 180. 91 and 67, somebody hook me up.
I go in my calculator.
158. Subtract 158 from both sides. So the measure of NBC is 22. Okay, so this angle is 22. Does that match angle L?
No.
So do we have two congruent angles?
No.
So can we say that they're similar? We cannot say they are similar. We do not have enough information. Not a mustache. So angle is the first way we can prove similarity. Our second one is side, side, side. Side, side, side similarity means all three corresponding sides have the same ratio. So the three sides, the three pairs of corresponding sides have all got to equal the same scale factor. So let's go to the next page because I've got three just waiting for you guys. So 10. The idea is the way we identify who pairs with who is we're going to pair the smallest with the smallest, middle with the middle, largest with the largest. So when we look at our two figures, because sometimes the orientation gets a little wacky. So like this guy right here, he was kind of sideways, kind of the other direction. So the way to make sure everybody's situated where they're supposed to be situated is smallest with smallest, middle with middle, large with large. So when we look at this triangle, what are my two smallest sides? 5 and 18. My middle sides, 43.2 and 12. And my largest sides, 15 and 54. So this one, it wasn't that bad, this little crooked bow tie, because you can kind of see where it needs to be. But I think this guy, he kind of helps us out with the right angle, but it'll still help that we organize by. We're going to take our three corresponding sides and set up a ratio that looks just like the ones we did on Wednesday where we set all three equal to each other. So AP corresponds with TY, TY. AR corresponds with TR. And the order that we put these in, guys, it doesn't matter. We just got to make sure we're putting the right people with the right people. And then PR coordinates with our YR. And then the other thing we've got to make sure is I've got ARP, all of their corresponding sides are in the numerator. TRY, all of its corresponding sides are in the denominator. I can't be mixing and flipping and doing all kinds of shenanigans. I got to make sure everybody's in their row. So AP, they give us 12. TY gives us 43.2. And then this is where our math frac button is going to be our big friend.
Oh, yeah.
Because we don't even know. AR over TR, so 15 over 54. And then we've got PR over YR. So when we go to put these guys into our calculator, okay, we can do the decimal, but let's just do math frac. If my wabbit shows up. What? So we're going 12 divided by 43.2. Math frac. 5/18. 15 divided by 54. Math frac. 5/18. And then what was our final one anyways? 5/18. So when we write these guys all out in their reduced form, are all three ratios the same? As long as that's true, we can prove similarity with side, side, side.
Yes.
So we've got ARP is similar to TRY. We haven't learned it, so I wonder if they want us to not say it's possible because we only have two sides, but we can find the missing side. I don't know. Maybe this note packet, they had learned the Pythagorean theorem by now. It is, but it doesn't show up till trig. Trigonometry. Proofs. Proof, there it is. Proof, there it is. It says, let's see. Yeah, it wants us to find that missing side. So let's go ahead and find it. I won't do this to y'all on y'all's homework or on your quiz or your test, but we can do the Pythagorean theorem together. It's not that bad. So the Pythagorean theorem is a squared plus b squared equals c squared, where c will always be your hypotenuse. And then A and B are just your other two legs. It doesn't matter what leg is A, what leg is B. The only thing that matters is our hypotenuse is labeled as C. So which one do we know will always be our hypotenuse? In the triangle itself. The one that's what? Opposite the right angle, right? Across from the right angle. So in XYZ, C will be 13 because it is opposite our right angle. So I'm just going to let a squared be our unknown side. Or do y'all want to label it XY? Will that help? So XY squared plus 5 squared equals 13 squared. Oh, I bet that other one's got a decimal. Oh, man. XY squared plus 25 equals 13. Is it a terminating decimal or an irrational number? Good. I'm cool then. Subtract 25. Oh, I forgot to square 13. 169. So XY squared equals 144. Okay, once I get to this step, how do I get rid of that square? You take the square root. Yep, square root both sides. Square root both sides. That eliminates the square on the left, and I get XY equals, what's the square root of 144? 12. So the Pythagorean theorem is not that bad. No. Which one's our hypotenuse? The big one. RV. So that's going to be on the right side. So RV squared equals 9 squared plus 21.6 squared. Go to our calculators. 9 squared plus. So we just go 9 squared plus. I'm listening. What's wrong, brother? Equals RV squared because that's our hypotenuse. 9 squared and 21.6 are our legs. Yeah. So when we do that, we get 547.56 equals RV squared. Okay, so 547.56 equals RV squared. And then I go back to my calculator. And if I just hit second x squared, and then I don't even got to type this in, I can go second answer, I get 23.4. Again, that will not be on your test on Wednesday for you guys. I could do it as a bonus.
I got a decimal.
Yes.
502.56
What?
equals RV squared.
547.56 equals RV squared, yes. And then you square root that.
Gotcha.
Second, and then the x squared button.
Oh.
But they ain't seen us together. Yeah, it's right there on the left below the, so go down 2 from math. Did you just keep pushing caret?
22.4.
Yeah, you've got your square button and your inverse button right there. So now we just need to check our side ratios. So remember, small, small, middle and middle, big and big. Who's our smallest sides? 5, yeah, we're still on 11. So 5 and 9. So it is kind of, they did kind of tilt it a little bit because you probably could have guessed like 21.6. And then our middle is 21.6 and 12. And then our tall ones, 13 and 23.4. So again, we need to set up our 3 ratios. So we got YZ over RW, W. XY over WV, and XZ over RV. Again, it doesn't matter who you put in the top, who you put in the bottom. It just matters that if the left triangle starts in the numerator, the rest of the sides need to be in the numerator. So we got 5 over 9. Hopefully that's what all our other ones reduced to, because that ain't going nowhere, is it? 12 over 21.6. And 13 over 23.4. By the way, that one on the left, this is called a Pythagorean triple. It's one of the ones that'll show up over and over again. 5, 12, 13 is a Pythagorean triple. 3, 4, 5, 5, 12, 13, 7. Oh, Peter, I have to look at them again. So we got 12 divided by 21.6. Not 21.69. Math. Frack. All right, 5 over 9. So we're 2 for 2. And then 13 divided by 23.4. Math. Frack. 5 over 9. So all 3 are 5 over 9. That was awful nice of them. So if that is true, are our triangles similar based on Side, side, side. Yep. So we would say XYZ is similar to who? VWR, right? Is that right? VWR? Thank you, guys. Side angle side. Sounds familiar, doesn't it? Okay, side angle side. So we can determine similarity using side angle side as long as we have two proportional sides and the included angle. So if you look at 14, our sides may have been proportional, but the congruent angle they gave me was not included between the green and the yellow. So there is no point in me wasting my time trying to find out if the sides are proportional. If the given angle, if the one we can conclude is not between the congruent sides, it cannot be similar based on side angle side. So this is kind of like donkey theorem. So let's see, 15. Oh, parallel lines. Everybody's favorite. Oh, yeah. Yeah, what you got? Oh, she's writing it in. So 15. They gave us parallel lines, which tells me I need to look for alternate interior or alternate exterior. So, or corresponding. I got alternate interior is probably not going to help me very much. But what could help me? Corresponding. So I've got a parallel line, cut by a transversal. What do I know about angle M and RPQ? Angle M and RPQ. So this angle and this angle. They are corresponding, so they are congruent. They are both below the transversal, with one inside the parallel lines, one outside the parallel lines. These are corresponding angles which we know are congruent. Before we continue, are my congruent angles between the congruent sides? Well, yeah, thank you. My proportional sides. So are they between them? Are they between them? So we need to check, are they proportional? So unlike 14, now our angles are between them, so we need to check. So we've got 54 over 33 equals 36. That's 32, dummy. Equals, slowly, 36 over 22. Now you've got a couple ways you can do it. You can just reduce the fractions to see if they're equal, or you can cross product to see if it's equal. I just like to reduce the fractions. So 54 over 33, 54 divided by 33, something with 11, I'm guessing, on the bottom. Math frac, 18 over 11. 36 divided by 22. Math frac, 18 over 11. So we go back to our problem. 18 over 11. Does 18 over 11 equal 18 over 11? Perhaps It does. And is my congruent angle between those proportional sides? Also, perhaps, so our triangles are similar. So what do we got? CMP? CMP is similar to RPQ. Number 17, the old triangle within a triangle. They love to trick you. But wait, so we've got WQR and WSZ. So where is our congruent angle? W, because it's a what? Shared angle. W is a shared angle. They are going to hit us with shared angle as much as they hit us with shared sides. They love the reflexive property. And by they, I mean the math institution. Fight the power. I am part of the math institution. I'm fighting from the inside for you guys. So we need to check. But the biggest thing here and what trips up QQ 15. And then what is the measurement of WS? That's why we got to be careful. Because people just say, oh, we haven't used the 30, let's just use the 30. And you're not the only one. You won't be the only one. So don't feel bad. Somebody's going to do it on the test and then like smack themselves upside the head. So the length is 45. What's the measurement of WR? And then what's the measurement of WZ? 42. Uh-oh. So nothing plus 1/3 equals 1/3 are our. Is my congruent angle included? All my angles similar. So we got RWQ, our RQW, right? What am I doing? No, RW. LMNOP, QR, yep, QRW is similar to SWZ. I'm listening. Oh, SCW. It does matter.
I mean, like, yeah, the second one does. The first one.
I mean, it doesn't, but it's the way it's supposed to look.